Hello everyone, so today we are starting with problems based on Newton Raphson method. So our first question is here, find the real root of the equation x cube minus 3x plus 1 is equal to 0 by Newton Raphson method. Okay, so now first we have to take the given equation to be equation 1. Let f of x, we'll take it as f of x is equal to x cube minus 3x plus 1, which is equation 1. Now to find x naught, that is to find the initial root which is next or near to the root of the given equation, what we have to do, that is to choose x naught. We have to do trial and error method, that is we have to just put some values for x and try getting first negative value, then positive value, as we did before for bisection method. That is f of 0 is equal to 0 cube minus 0 plus 1. That means it is equal to 1, which is greater than 0. Next, f of 1, I'll try. So we have a 1 cube minus 3 into 1 plus 1. That is equal to 1 minus 3 is minus 2. Minus 2 plus 1 is minus 1, which is less than 0. So we know that the root lies between 0 and 1. Root lies between a and b, remember? So root lies between 0 and 1. So we will go a little more closer to the root. That means in between this only the root lies, right? So we will try 0.1234 so that we'll come little more closer to the root which is between this. Okay, so we will try 0.5. So that is 0.5 the whole cube minus 3 into 0.5 plus 1, that is equal to minus 0.375, which is less than 0. Okay, that means the root lies between the negative number and the positive number, right? That means the root lies between 0 and 0.5. Now we will go a little more closer to the root. That means we will try 0.4. Okay, 0.4 the whole cube minus 3 into 0.4 plus 1 is equal to minus 0.136, which is less than 0. Now again compare the previous positive root. Previous f of x which is positive is this. That means root lies between 0 and 0.4. Going little more closer to the root, we will check for 0.3. That is 0.3 the whole cube minus 3 into 0.3 plus 1. That gives you 0.127, which is greater than 0. That means the root lies between the previous negative f of x, right? This is positive. The previous negative is this. That means the root lies between 0.4 and 0.3. So I can consider the x naught here to be either 0.4 or 0.3, but I'll take 0.3. So choosing x naught is equal to 0.3. I'll take x naught to be 0.3. Now what is our formula? Formula is x naught, x1 is equal to x naught minus f of x naught divided by f dash of x naught. So in order to do that, we should know f of x and f of x naught, right? Sorry, f of x naught and f dash of x naught, right? Yes. So we will find what is f of x naught and what is f dash of x naught for the formula. So f of x naught is nothing but f of 0.3. So you will get 0.3 the whole cube minus 3 into 0.3 plus 1, which is, we already found that, right? 0.127. We will find f dash of x naught. In order to find f dash of x naught, we should know what is f dash of x, right? So f of x is 3x cube minus 3x plus 1. So differentiate that once, we get 3x square minus 3 plus differentiation of the constant is 0. So now finding f of x naught, f dash of x naught, it is f dash of 0.3. That means 3 into 0.3 the whole square minus 3. That gives you minus 2.73 So now we will do our first approximation. So first approximation can be done using the formula x1 is equal to x0 minus f of x0 divided by f dash of x0. Substituting the values of x0, we get 0.3 minus f of 0.3. We got it already, right? F of 0.3 was 0.127 divided by f dash of x0 was minus 2.73. So which I am substituting here. Now calculate this. What do we get as x1 value? That is 0.346520. Okay, so now as soon as we get x1, our aim is to find f of x1 for the next formula, f of x1 as well as f dash of x1. So what is f of x1? Substituting the values of x1 in f of x. So we have f of x here. Substituting the value in the place of x, you have to put 0.346520. So we get 0.346520 the whole cube minus 3 into 0.346520 plus 1. So that gives you f of x1 value, which is nothing but 0.002048. Now find f dash of x1. That's nothing but f dash of x is this. That means 3 into 0.346520 the whole square minus 3. So we get f dash of x1 value to be minus 2.639771. Okay, so now our second approximation can be done using the formula change x1 to x2, 0 to 1, 0 to 1, 0 to 1. Okay. Our second approximation is x2 is equal to x1 minus f of x1 divided by f dash of x1. Substituting x1 value, f of x1 value, f dash of x1 value, I get this. Simplify this, I'll get x2 value to be 0.347295. Now finding f of x2, we get 0.000035 is equal to 3.5 into 10 to the power of 5. So here, once after the decimal place, if we get 4 places to be 0, that means we have got the root accurate to 4 places. Okay, we can stop here and say x2 is the root of the given equation. So according to some textbooks it's like this, according to some other textbooks it's like as we did bisection method, right? Like we were comparing the previous x1 and the next previous x and the next current x, that is now we have x2, we will compare it with next x3, and if it is similar to 4 digits or 3 digits, similar values we are getting, we can say that that is a root of the equation. So either which method is easy for you, you can follow that, but we are going to follow this one, f of x2 after decimal point 4 zeros, if 4 places if you get 0, you can stop there and say that is the root of the given equation. Now we have x2 as the root of our equation. So x2 value is 0.347295. We have to correct it up to 4 decimal places, right? So in order to correct it up to 4 decimal places, we have to see 1, 2, 3, 4th digit is 2. 5th digit is above 5. That means we have to add one number to this one. Our answer becomes 0.3473. Hence the approximate root corrected up to 4 decimal places is x is equal to 0.3473. Don't forget to write the conclusion. Okay, always write the conclusion for all the problems.